video for Geometric Series, their Convergent, and Other Convergent Series by Jacob Tankersley and Tommy Tran. So today we're going to be going over infinite geometric series as well. And here we have notes on these geometric series. And pretty much what this is saying is that an infinite geometric series is convergent as long as r, the magnitude of r is less than 1, and the sum from n equals 1 to infinity of a of r to the n minus 1 is equal to a over 1 minus r, where that r value is still less than 1. And this series will be divergent if the magnitude of r is greater than or equal to 1. So here we have some examples, and these will remind you that the summation from n equals 1 to infinity of a of r to the n minus 1 is equal to a over 1 minus r as long as r is less than 1. So example A we have here is just an example of a simple series, and it's 2 plus 4 plus 8 plus 16. And so here, since every number is multiplied by 2, r is equal to 2, which is pretty much the constant that each consecutive number is multiplied by. So since r is equal to 2, this series is therefore divergent. On our next example, we have the series 8 plus 4 plus 2 plus 1. So here we see each number is getting consecutively smaller. And so each consecutive number is multiplied by a constant, which happens to be 1/2 in this case. And so since 1/2 is less than 1, this series is therefore convergent. Which, going back to part A, since 2 is greater than 1, or greater or equal to 1, we can say that that is divergent. So, on to our next page. So next we're going to go over pretty much series that you're going to need to know over your time in Calculus BC for the AP exam, etc. And we're going to go over each of these one by one, and I'll explain to them how important each one is. So, need to know series. And the first series we have is 1 over 1 minus x is equal to 1 plus x squared plus x cubed plus ... x to the n, which would also be equal to the sum from infinity from n equals 0 of x to the n. Which, I mean, that's just another way it could pretty much be said right there. But you won't need to know that as much as you need to know everything else. And here we have, since this is a geometric series, we are given that the interval of convergence is the magnitude of x is less than 1. So I'll give you a couple seconds to write that down. On to our next series. So here we are, we have 1 over 1 plus x squared. And it is equal to 1 minus x squared plus x to the 4th minus x to the 6th ... which is negative 1 to the n minus 1 times x squared to the n minus 1. And the interval convergence for this is also, since it's a geometric series, it's the magnitude of x is less than 1. But mainly while I'll let you write this down, for about all these series, it's really going to come down to memorization for this, because you will have multiple FRQs and multiple choice questions that'll come down to you knowing these series and being able to manipulate them. And our next series is 1 over 1 plus x, which is equal to 1 minus x plus x squared minus x cubed, plus negative x to the n minus 1, which with an interval of convergence of x, of the absolute value of x is less than 1. Which pretty much all this is an alternating version of 1 over 1 minus x. Our next series, and arguably the most important, is e to the x, which is equal to 1 plus x squared over 2 factorial plus x cubed over 3 factorial, plus x to the n all over n factorial, which, just so you know, these last terms in all of our series will be the general term. And this actually has an interval of convergence of all real numbers. Our next series would be cosine x, which is equal to 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th all over 6 factorial plus x to the 2n all over 2n factorial. And this also has an interval of convergence of all real numbers. And just so you know, for sine x, how I know the exponents and the type of factorials we have on the bottom is that this is an even series, which means it will have even exponents and even factorials. Our next series is sine x, or I'm sorry, even exponents, my bad. Sine x is equal to x minus x cubed all over 3 factorial plus x to the 5th all over 5 factorial plus negative 1 to the n minus 1 times x to the 2n minus 1 all over 2n minus 1 factorial. And this also has an interval of convergence of all real numbers. And I know what type of exponents in the factorial we have is because sine x is an R series, which is different than cosine x, which is even. Our next series we have is ln of 1 plus x, which honestly, if you look at it, it's just the integral of 1 over 1 plus x. See? That's an easy way to remember ln of 1 plus x, which is x minus 1/2 x squared plus negative 1 to the n minus 1 x to the n all over n. But this has a weird interval of convergence with negative 1 on the open to 1 on the closed. Next we have arctan of x, which is equal to x minus 1/3 x cubed plus 1/5 x to the 5th plus negative 1 to the n x to the 2n plus 1 all over 2n plus 1, with an interval of convergence of negative 1 on the closed to 1 on the closed. And I remember arctan of x by just thinking of what is the antiderivative of 1 over 1 plus x squared. And so whenever you think of it that way, that's also another one that's fairly easy to remember. On to our next series, we have 1 all over 1 minus x squared, which is equal to 1 plus 2x plus 3x squared plus nx to the n minus 1. And this one is a geometric series as well, so it has an interval of convergence of the magnitude of x is less than 1. And a bonus series you should probably know, but isn't specified in this specific video, is the harmonic series, which is always divergent and is 1 over n. So just so you know, that is the harmonic series. And in case you want to write that down, there it is. So now we are going to do a multiple choice practice problem. The question is, what is the approximation of the value of sine of 1 obtained by using the 5th degree Taylor polynomial about x equals 0 for sine x? So we should all know sine x, which means we should probably write that down. So as we know, sine of x is equal to 1 minus x cubed all over 3 factorial plus x to the 5th over 5 factorial, which it only said 5th degree, so we go to to the 5th. So all we have to do from here is plug in 1 for sine x, and what we'll get is sine of 1 is equal to 1 minus 1 over 3 factorial plus 1 over 5 factorial. And then after simplifying this, we will get 1 minus 1 over 6 plus 1 all over 120. And so the correct answer to this ended up being E, which is 1 minus 1/6 plus 1/20. And now we come to the FRQ problem. And I know that everyone just absolutely adores FRQs because they are just the funnest thing I know of, especially in calculus, because calculus is wonderful. So it says right here that f of x is equal to cosine of x cubed plus sine of x squared. And here it says part A, it says we are supposed to write the first 4 non-zero terms of the Taylor series for sine of x about x equals 0, and write the first 4 non-zero terms of the Taylor series for sine of x squared about x equals 0. So it said to write the first 4 terms for the Taylor series of sine x. So we're just going to say sine x is approximately the Taylor series, and I'm going to put S here for sine, which is equal to x minus x cubed all over 3 factorial plus x to the 5th, x to the 5th all over 5 factorial minus x to the 7th all over 7 factorial. And so here, and then it says, also write the first 4 non-zero terms. You see I only did 4 for sine of x squared. So I'm sure you're thinking, well, I don't know sine of x squared. Well, yeah, you do. All you have to do is plug in x squared into x. And so what you'll have is x squared minus x to the 6th, because 2 to the 3rd is 6th. And then you do that for the remaining terms, and you'll get x to the 10th all over 5 factorial minus x to the, 14th all over 7 factorial. And so that is all the points for part A. It is very easy points that you should not miss once it comes AP time. Part B. So here it says write the first 4 non-zero terms of the Taylor series for cosine x this time, and write the first 4 non-zero terms of for cosine of x cubed. So first we just need to write cosine x is approximately, because it's not completely equal to the Taylor series, of t of c of x, which would be equal to 1 minus x squared all over 2 factorial plus x to the 4th all over 4 factorial minus x to the 6th all over 6 factorial. Okay, so after we do cosine of x, we're supposed to find cosine of x cubed, which, the same as part A, is just approximately t of c of x cubed, though, instead of x squared, and we'll plug x cubed into this series. So this will end up being 1 minus x to the 6th, because 3 times 2 is 6, so x cubed squared is x to the 6th, all over 2 factorial, plus x to the 4th, all over 4 factorial. Oh man, I'm sorry. That's not right. X to the 12th. See, I can't even do math. Minus x to the 18th, all over 6 factorial. So there's all your points for part B right there. We found cosine of x cubed and cosine of x. So then we go to part C, which says, using the solutions found in parts A and B, write the first 4 non-zero terms of the Taylor series for f about x equals 0. So we know that f of x is equal to cosine of x cubed plus sine of x squared. And so once we do this, really essentially what we're going to do is just add cosine of x cubed, which is 1 minus x to the 6th all over 2 factorial, plus x to the 12th all over 4 factorial, minus x to the 18th all over 6 factorial. Oh man, getting caught on the table here. Plus sine of x squared, which is x squared plus, minus x to the 6th all over 3 factorial, plus x to the 10th all over 5 factorial, minus x to the 14th all over 7 factorial. Okay, I started running out of room there. So I'm going to move further over now. So then here, you just start combining the series. So you have 1 minus, plus x squared. And so we have the 1 taken care of, we got rid of the x squared. And then now we have a negative x to the 6th all over 2 factorial minus x to the 6th all over 3 factorial, which those are the only two common terms. So once you combine those, you end up getting negative 2x to the 6th all over 3. And then after doing that, you just mark those off the list, and then you do plus x to the 10th all over 5 factorial. And so we don't have to add any of these other ones because that was our last term. We have 1, 2, 3, 4, and that is the answer to part C, which ends up being the solution to f of x using what we found here. This is the Taylor series. Thank you for watching this video, and we hope to help.